Hello friends, welcome to my channel Master the Monster. Let's enter into the world of polynomials. Trust me, this is going to be an easy and interesting section of mathematics. You may have few doubts and questions regarding polynomials, the degree of polynomials, zeros, division of polynomials, what are quadratic polynomials, geometric meaning, all those things in your mind. No worries, let us sort out all the questions one by one. Before that, subscribe to my channel so that you will enjoy learning maths. Okay, in our previous video, we have seen what are zeros of a polynomial and what are their geometric meaning. Now we are going to see how to find the zeros of a quadratic polynomial, and I am going to explain you the splitting method to find the zeros of a polynomial. Okay, I'll explain it a step by step clear way and listen to it carefully so that this will be very helpful for you to solve problems in your exercise 1.2.2, right? Okay. Now let me consider a quadratic polynomial 6x square minus 5x plus 6. So you are given a quadratic polynomial. See, the degree is 2, therefore it's a quadratic polynomial. Now I am going to find the zero of this polynomial. And we have seen it is a quadratic polynomial, then it has at most 2 zeros. Just now in our previous video we have discussed that. So this polynomial is going to have 2 zeros. Let's find out them. Right? Okay. Now we'll compare this with the standard form of a quadratic polynomial. The standard form of quadratic polynomial is ax square plus bx plus c. And you are given 6x square minus 5x minus 6. So when you compare the coefficients, I get a equals 6, b equals 5 and c equals 6. Alright? Okay. Now we'll see what is the first step to find the zeros of quadratic polynomial. The first step is that find two numbers L and M such that L plus M equal B and LM equal AC. That is, I am going to get two numbers whose sum, that is L plus M, is B, that is minus 5. And whose product, that is LM, is A into C. A is 6, C is minus 6, so the product is minus 36. So we are going to find two numbers whose sum is minus 5 and product is minus 36. And I know that 9 fours are 36. So the two numbers are 9 and 4. But I have the product as minus 36. So if the product is minus, then any one of the factors should be negative. So suppose I take here 9 into minus 4, then I get minus 36. But you see, when you add the two numbers, find the sum, it will not be minus 5. Here the sum is also negative, right? So if the sum is negative, then you automatically shift the minus sign to the bigger number. So whenever the sum of the terms and product of the terms are negative, you take the bigger number to be the negative number. Okay. So now I have found L and M, that is the two numbers whose sum is B and product is AC, and they are minus 9 and 4. So this is my step 1, finding two numbers whose sum and product are. Okay. Now let's go to step 2. Step 2 is split the middle term bx as lx plus mx. So now this is my polynomial and minus 5x is the middle term. This is bx, isn't it? Bx is the middle term. I have split it as lx and mx. L is minus 9, m is 4. So it's minus 9x and 4x. So this is step 2. We understand step 1 we have got two numbers L and M. And in step 2, I have split the middle term into two terms, that is Lx plus Mx. Now we'll move on to step 3. The step 3, get the factors by grouping the terms. Okay, now I'm going to group the terms. I'm going to group the first two terms and the next two terms. Okay. Now let's consider the first two terms. I can take some factors common outside. From the two terms, I can take a 3x common outside, so that the remaining term will be 2x minus 3. So from first two terms, I have taken 3x common outside, so that I get the remaining term as 2x minus 3. Similarly, from the next two terms, I take plus 2 common outside. a plus sign and a 2 common outside. Therefore, the remaining will be 2x minus 3. Now we see that in both the cases, you have 2x minus 3 common. So let me take the 2x minus 3 common outside. Therefore, the remaining factor will be 3x plus 2. Okay, so this is how I find the factors by grouping the terms. Now I have grouped the terms and got the factors of given polynomials as 2x minus 3 and 3x plus 2. These are the factors of the polynomial, 2 factors. Since it is a quadratic polynomial, I get 2 factors. Okay, now we'll proceed to step 4. Step 4 is equate the factors to 0 and get the zeros of the polynomial. See, actually I'm going to find the 0 of the polynomial, isn't it? So by definition, what is 0 of a polynomial? The value of x for which the value of polynomial itself becomes 0. So I need the value of the polynomial to be 0. So for which value of x I get the polynomial to be 0. That's what I have to find. So I equate the factors to 0 and get the zeros of the polynomial. Now let's equate the factor one by one. And here I have 2x minus 3 into 3x plus 2 equals 0. The product of two terms is 0 means then any one of these numbers should be 0. So I can say either 2x minus 3 equals 0 or 3x plus 2 equal 0. Right? So because multiplication is 0, then any one of the factor must be 0. Now let me take the first term, 2x minus 3 equals 0. So if 2x minus 3 equals 0, let me simplify. Take 3 to the other side and 2 to the other side. I get x equal 3 by 2. Similarly, let's consider 3x plus 2 equals 0. That is the other possibility. And take 2 to the other side, it becomes minus 2. And 3 to the other side, it becomes by 3. So I have got x values to be 3 by 2 and 2 by 3, minus 2 by 3. These are the two zeros of the quadratic polynomial. So these are the zeros. X equal 3 by 2 and x equal minus 2 by 3 are the zeros of the quadratic polynomial 6x square minus 5x minus 6. So this is how I find the zero of a quadratic polynomial by splitting method. First step, I find two numbers L and M such that their sum is B and product is AC. Then I split the middle term as Lx plus Mx. Then I group the terms and find the factors. Then I equate the factors to 0 and get the zeros of the polynomial. So this is the splitting method of zeros of quadratic polynomial. Hope you are clear with it. Thank you. Okay, now we'll see the relationship between zeros and coefficients of a polynomial. This is the next important section of this unit. Okay, now consider the quadratic polynomial p of x equal ax square plus bx plus c, and it's a quadratic polynomial and we know that it has two zeros, so let them be alpha and beta. Okay, now the relation between zeros and coefficients are given by sum of zeros equal coefficient of minus coefficient of x by coefficient of x square, and product of zeros equal constant term by coefficient of x square. That is, sum of zeros means here the zeros are alpha and beta, and the coefficient of x is b and the coefficient of x square is a. So I get sum of coefficients is alpha plus beta equal minus b by a. Similarly, product of zeros means it's alpha into b and the constant term is c and the coefficient of x square is a. Therefore, alpha into beta equals c by a. So alpha plus beta equal minus b by a, and alpha beta equal c by a are the relations between the zeros and coefficients. Okay, now let's verify this relationship for a polynomial. Of course, a quadratic polynomial p of x equals 6x square minus 5x minus 6. Okay, now comparing it with ax square plus bx plus c, I get a equal 6, b equal minus 5 and c equal 6. And just now we have found the zeros of this polynomial as alpha equal 3 by 2 and beta equal minus 2 by 3. So just now by splitting method we have found the zeros. Okay. So let me take those zeros as alpha and beta. Okay, now let me verify the first relation, that is alpha plus beta equal minus b by a. Let me find what is alpha plus beta. Alpha plus beta is, alpha is 3 by 2 plus beta is minus 2 by 3. When we take LCM and add it, we get the value to be 5 by 6. Okay, so alpha plus beta is 5 by 6. Now let me see what is minus b by a. Minus b by a equal to minus b is minus 5. So minus 5 by 6. That is minus into minus plus, so we get 5 by 6. Hence we have verified that alpha plus beta equal minus b by a. Both the values are 5 by 6. Okay. Now we'll see what is alpha into beta. Alpha into beta, multiply the two roots 3 by 2 and minus 2 by 3. So when multiplying, we can cancel 3 and also cancel 2, so that you get alpha into beta equal minus 1. Now let me see what is c by a. C by a is equal to, c is minus 6 and a is 6. Therefore it is minus 6 by 6. Here again I can cancel 6 and get the value to be minus 1. So in this case I have verified alpha beta equal c by a. So this is how we verified the relation between the zeros of a polynomial and the coefficients of a polynomial, that too a quadratic polynomial. Similarly, we can see the relationship between the zeros and coefficients of a cubic polynomial. Consider the cubic polynomial p of x equal ax cube plus bx square plus cx plus d. Since it is a polynomial of degree 3, we have 3 zeros. Let them be alpha, beta and gamma. Now, as usual, sum of zeros equal minus coefficient of x square by coefficient of x cube. So, sum of zeros means it is alpha plus beta plus gamma equal to minus coefficient of x square is b and coefficient of x cube is a. Therefore, I get alpha plus beta plus gamma equal minus b by a is the first relation. Sum of product of zeros taken 2 at a time is coefficient of x by coefficient of x cube. Product of zeros taken 2 at a time means it is alpha into beta plus beta into gamma plus gamma into alpha. That's what we are going to find. So, alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x is c and coefficient of x cube is a. That's equal c by a is the next relation. And then we have the final is product of zeros. The product of zeros is minus constant term by coefficient of x cube. That is alpha beta gamma equal constant term is d. So minus d by a. So these three are the three relationships between the zeros of the cubic polynomial and the coefficients of the cubic polynomial, right? Hope you all very well understand how to find zeros of a polynomial and what is the relation between the zero of a polynomial and the coefficients of a polynomial. Okay, with this we'll proceed to the exercise 2.2.